Hello, welcome to GTech Techno Solution Private Limited. We are going to discuss about structural analysis. Let us see a few interview tips on structural analysis. A question is, why is it necessary to compute deflections in structures? The answer is, if the deflection of a structure is more than permissible, then the structure will not look aesthetic. Hence, this will cause a psychological upsetting of the occupants. Thus, excessive deflection may cause cracking in the materials attached to the structure. For example, if you see the deflection of a floor beam is excessive, then the floor finishes and partition wall supported on the beam may get cracked or unserviceable. So these are the risks of deflections in structures. Moving on to our next question, we have, what is meant by cambering technique in structures? Cambering is a technique applied on site in which a slight upward curve is made in a structure or beam during the construction so that it will straighten out and attain a straight shape during loading. This will considerably reduce the downward deflection that may occur at later stages. Moving on to our next question, we have, name the methods used for computation of deflections in structures. So the methods that are used for computation of the deflections in structures include double integration method, Macaulay's method, conjugate beam method, method of elastic weights, moment area method, virtual work method, dummy unit load method. So these are the various methods that are used for computation of deflections in structures. Moving on to our next question, we have to state the difference between strain energy method and unit load method in the determination of deflection of structures. In strain energy method, an imaginary load, say P, is applied to the point where the deflection is desired to be determined. P is equated to 0 in the final step and the deflection is obtained. In unit load method, an unit load instead of P is applied at the point where the deflection is desired. So by doing this, you can find the strain energy method and unit load method in determining the deflection of the structures. Moving on to our next question, we have the question as, what are the assumptions made in unit load method? If you see, in unit load method, the external and internal forces are in equilibrium. Its supports are rigid and no movement will be possible. So, the materials are strained well with the elastic limit. So, these are the assumptions that are made in unit load method. So, using these assumptions, we can calculate using the unit load method Moving on to our next question we have, what is meant by thermal stress? Thermal stresses are the stress developed in a structure member due to the change in temperature. Normally, determined structures do not develop thermal stress. They can absorb changes in length and consequent displacement without developing stress. So this is what is meant by thermal stress. It is the stress developed in a structure or a member due to temperature. Moving on to our next question we have, what is the effect of temperature on the members of a statically determinate plane truss? In determinate structures, temperature changes do not create any internal stresses. The changes in the length of the members may result in displacement of joints, but these would not result in internal stresses or changes in external reactions. So thus, the effect of temperature on the members of a statically determinate plane truss will not result in internal stresses or changes in external reactions. Moving on to our next question we have, define static indeterminacy of a structure. If the conditions of the statics, that is, summation of h is equal to 0, summation of v is equal to 0 and summation of n is equal to 0 alone are not sufficient to find either external reactions or internal forces are in a structure. The structure is then called as statically indeterminate structure. Our next question is, define trussed beam. Truss beam is nothing but a beam that is strengthened by providing ties and struts. So by using your ties and struts, if a beam is built, then it is known as trussed beam. Our next question is, define unit load method. Unit load method is nothing but the external rho is removed and the unit load is applied at a point where the deflection or the rotation is to be found. So by doing this, you can determine the flexibility of the structure. So that is meant by unit load method. Our next question is, give the procedure for unit load method. To find the unit load method, we have to follow the procedure as first. You have to find the forces P1 and P2 in all the members due to external loads. You have to remove the external loads, and then you have to apply a unit vertical point load at the joint. If the vertical deflection is required, then you have to apply unit vertical point load, and then you have to find the stress. So apply the equation for vertical and horizontal deflection. By doing this, you can apply your unit load method. Our next question is, where do you get rolling loads in practice? Shifting of load positions is common enough in buildings where we'll be getting of rolling loads in practice, but they are more pronounced in bridges and gantry. Girders over which the vehicles keep rolling. So, rolling loads are more pronounced in bridges and in gantry girders. Our next question is, name the type of rolling loads for which the absolute maximum bending moment occurs at the midspan of a beam. The type of rolling loads for which the absolute maximum bending moment occurs is single concentrated load, UDL longer than the span, UDL shorter than the span. When the resultant of several concentrated loads crossing a span coincides with a concentrated load, then also the maximum bending moment occurs at the center of the span. So, thus, the type of rolling loads occurs at the midspan of a beam. For which the absolute maximum bending moment occurs. Our next question is, what is meant by absolute maximum bending moment in a beam? If you consider when a given load system moves from one end to the other end of a girder, then depending upon the position of the load, there will be maximum bending moment for every section. So the maximum of these bending moments will usually occur near your midspan. So the maximum of the maximum bending moments is known as absolute maximum bending moment. So the maximum of maximum is your absolute maximum bending moment.